What is the main motivation behind the study as outlined in the introduction of the paper?
The main motivation behind the study outlined in the introduction of the paper is to investigate the empirical success of current multimodal models like clip and stable diffusion through the lens of zero-shot generalization. The study aims to determine if these models are truly capable of zero-shot generalization, which refers to their ability to apply learned knowledge to new unseen concepts. The research seeks to address this by conducting a comparative analysis involving two main factors: the performance of models across various downstream tasks and the frequency of test concepts within their pre-training datasets. The study aims to understand the relationship between concept frequency in pre-training datasets and model performance on zero-shot tasks, highlighting the extreme sample inefficiency and the exponential need for training data as a fundamental issue for current large-scale multimodal models.
How does the paper define zero-shot generalization in the context of multimodal models like clip and stable diffusion?
The paper defines zero-shot generalization in the context of multimodal models like clip and stable diffusion as the ability of the model to apply its learned knowledge to new unseen concepts without any prior exposure during training. It specifically refers to the model's capability to generalize to concepts that were not present in the pre-training dataset. The paper investigates whether current multimodal models can truly achieve zero-shot generalization by analyzing the performance of these models across various downstream tasks and examining the frequency of test concepts within their pre-training datasets. The study aims to determine if the impressive empirical performance of models like clip and stable diffusion can be attributed to their ability to generalize to unseen concepts, or if their performance is heavily reliant on the presence of test concepts within their vast pre-training datasets.
What are the two main factors investigated in the comparative analysis conducted in the study?
The two main factors investigated in the comparative analysis conducted in the study are: 1. The performance of models across various downstream tasks. 2. The frequency of test concepts within their pre-training datasets. The study compiled a comprehensive list of 4,029 concepts from 27 downstream tasks spanning classification, retrieval, and image generation to assess the performance against these concepts. Additionally, the analysis spanned 5 large-scale pre-training datasets with different scales, data curation methods and sources, evaluating the performance of 10 clip models and 24 T2I models across different architectures and parameter scales. The study consistently found that the frequency of a concept in the pre-training dataset is a strong predictor of the model's performance on test examples containing that concept, indicating a log-linear scaling trend. This analysis aimed to investigate the empirical success of multimodal models like clip and stable diffusion through the lens of zero-shot generalization, focusing on the ability of the models to apply their learned knowledge to new unseen concepts.
How many concepts were compiled for assessment across 27 downstream tasks in the study?
In the study, a total of 4,029 concepts were compiled for assessment across 27 downstream tasks.
What is the key finding regarding the relationship between concept frequency in pre-training datasets and model performance?
The key finding regarding the relationship between concept frequency in pre-training datasets and model performance is that there is a clear log-linear scaling trend observed across various tasks and model types. This trend indicates that as the concept frequency in the pre-training data grows exponentially, the model performance scales linearly. This log-linear relationship persists consistently across different model architectures, parameter scales, pre-training datasets with varying curation methods and evaluation metrics. The study shows that current multimodal models exhibit data-hungry learning behavior, as they require exponentially more data on a concept to linearly improve their performance on tasks related to that concept. This finding highlights the lack of sample efficiency in current large-scale multimodal models and suggests that their impressive empirical performance is largely attributed to the presence of test concepts within their vast pre-training datasets, rather than true zero-shot generalization capabilities.
How does the paper describe the distribution of concepts encountered in pre-training data?
The paper describes the distribution of concepts encountered in pre-training data as long-tailed. It notes that over 2/3 of concepts occur at almost negligible frequencies relative to the size of the datasets. This long-tailed distribution is consistent with past observations in large-scale language datasets. Despite the vast differences in dataset sizes and curation strategies, there is a surprisingly high correlation in concept frequencies across the datasets analyzed. This correlation suggests that datasets derived from the Internet exhibit similar, long-tailed behavior due to the common source of web crawls. The paper also highlights the misalignment between concepts in image-text pairs in the pre-training datasets, quantifying the degree of misalignment and providing insights into the challenges posed by this misalignment.
What methodology is outlined for obtaining concept frequencies from text captions in the pre-training datasets?
The methodology outlined for obtaining concept frequencies from text captions in the pre-training datasets involves several steps. First, common and proper nouns are isolated using part-of-speech tagging. These nouns are then lemmatized to standardize word forms. The lemmatized nouns are cataloged in inverted unigram dictionaries, where each noun is the key and all the indices in the pre-training data samples containing that noun are its values. To determine the frequency of a concept, individual unigrams within these dictionaries are examined. For multi-word expressions, the lists of sample indices corresponding to each unigram are intersected to identify samples containing all parts of the concept. The frequency of the concept in the text captions is then determined by counting these intersecting sample indices. This frequency estimation algorithm allows for efficient search with respect to the number of captions for any given concept in the pre-training dataset captions.
How are concept frequencies estimated from images in the pre-training datasets?
Concept frequencies from images in the pre-training datasets are estimated by collecting all 4,029 downstream concepts and verifying their presence in images using a pre-trained image tagging model, specifically the RAM++ model. This model tags images based on a predefined list of concepts in a multi-label manner, indicating whether the downstream concepts are present or not in each image. By tagging images with the presence or absence of concepts, concept frequencies can be computed. This approach allows for scalable concept frequency estimation from images in the pre-training datasets. The use of the RAM++ model was found to perform the best among various open vocabulary object detectors, image text matching models, and multi-tagging models tested for this purpose.
What is the significance of combining text and image searches to calculate matched image text concept frequencies?
Combining text and image searches to calculate matched image text concept frequencies is significant because it allows for a comprehensive view of concept representation across the dataset. This is crucial due to the observed significant image-text misalignment between concepts in the pre-training datasets. By identifying pre-training samples where both the image and its associated caption correspond to the concept, the method ensures that the concept is accurately represented in both modalities. This approach addresses the issue of misalignment, where captions may not reflect what is present in the image, and vice versa. The combination of text and image searches provides a more accurate and holistic understanding of how concepts are represented in multimodal datasets, which is essential for analyzing the relationship between concept frequency and model performance in zero-shot tasks.
What experimental approach is detailed in the experimental setup section of the paper?
The experimental approach, detailed in the experimental setup section of the paper, involves analyzing two classes of multimodal models, image-text and text-to-image. The setup includes detailing the pre-training and testing datasets, along with their associated evaluation parameters. This approach aims to establish the relationship between image-text matched pretraining concept frequencies and zero-shot performance across classification, retrieval, and generation tasks.